Welcome, brothers, to this explainer on installing and setting up the EZ1000 series online analyzer. Specifically, we're going to be looking at the EZ106.99 model for free chlorine. I am absolutely thrilled to guide you through this process today. We're zeroing in directly on the water inlet of your RO system, and as engineers managing UPW pure water filtration systems, you already know that precision here is literally everything. Our main focus today? Getting this automated colorimetric analyzer perfectly dialed in.
So let's talk about the why. Why is this so absolutely crucial? Well, missing this step or getting this setup wrong means permanent catastrophic damage to your RO polyamide membranes. Controlling residual chlorine at the RO inlet isn't just a best practice, it's a hard requirement to protect those membranes from rapid oxidation. If we let those levels exceed the allowable limits, the damage is irreversible. We're talking membrane lifespan dropping straight to zero.
All right, here is our roadmap for today's installation. We'll start with safety and equipment check, then move into mechanical and piping installation. After that, electrical and SCADA integration, followed by chemical reagents and calibration. Then we'll cover parameters and final handover and wrap it all up with interferences and data mapping.
Okay, let's kick things off with Section 1, Safety and Equipment Check.
Before we even touch a single piece of equipment, brothers, your safety protocols have got to be locked in tight. You must be fully equipped with PPE, chemical-resistant rubber gloves, safety glasses, your hard hat, and steel-toe insulated shoes. Next, execute a strict lockout-tagout on the electrical system before making any connections, no exceptions. You also need to guarantee your installation area has proper ventilation to prevent chemical vapor buildup, and absolutely verify that your emergency eye wash and first aid kit are within 10 meters before you even think about handling the DPD chemicals. Now for the fun part. Unbox your EZ100699 analyzer on a clean surface right in your tech room. Carefully cross-check your bill of materials to ensure nothing went missing in transit. You are specifically looking for the DPD reagent kit, the tubing kit, the flow cell, and your instruction manual. Make absolutely sure there's no shipping damage before you sign off on receiving the equipment. Moving right along to Section 2, Mechanical and Piping Installation. First up, I need you to find a prime location right near the RO feed sampling point. Ideally, this is after the raw water pump, before the high-pressure pump. Keep it completely out of direct sunlight and away from any external heat sources. The ambient temperature must strictly remain between 5 and 40 degrees Celsius. Furthermore, you have to maintain a minimum 100 millimeter clearance from the analyzer to the wall or any adjacent cabinets. And this isn't just for maintenance access, It's completely critical for thermal ventilation.
Time to mount the wall bracket. Secure it using heavy-duty anchor bolts, ensuring the whole thing is perfectly level. Then, go ahead and route the white and blue sample line from the main RO feed. Now, this line must go through the brass pressure regulator to appropriately drop the pressure for the flow cell and then through a flow control valve. You'll want to dial in a nice steady flow reading, somewhere between 100 and 300 milliliters per minute on your rotometer. Finally, route your gray waste line directly into a safe chemical drain. No floor leaks allowed on our watch.
Let's dive into Section 3, Electrical and SCADA Integration.
Let's get some power to this unit. Wire your 100 to 240 volt AC power via a dedicated, labeled breaker. Now, crucially, you must torque down that green and yellow protective earth ground wire right to the common bus bar. Grab your multimeter and verify that the grounding resistance is strictly under 4 ohms. This protects you from shocks for sure, but just as importantly, it eliminates electromagnetic interference that will otherwise severely distort your highly sensitive analog measurements.
For data integration, connect your shielded, twisted pair 4 to 20 milliamp outpacks directly to your PLC's analog input module. And hey, if your specific architecture demands it, hook up the RS-485 terminal for Modbus RTU communication. Next, set your hard relay outputs. We need to trigger a high alarm at 0.5 milligrams per liter, that's our membrane danger zone, right? And a low alarm at 0.05 milligrams per liter to ensure our primary disinfection hasn't actually failed upstream.
All right, Section 4, Chemical Reagents and Calibration.
Wearing your chemical-resistant gloves and safety goggles, open up that front compartment. Install the DPD reagent and buffer bottles firmly into their designated slots right on the white plastic tray. Carefully connect the color-coded Tygon tubing exactly as it's mapped out in the manual. Once everything is securely connected, press the prime button to fire up the peristaltic pump. You must purge every single air bubble out of those chemical lines. Seriously, not a single bubble can remain. Let's move on and actually build our calibration curve.
First, run completely chlorine-free water, like pure RO or DI water, through the flow cell. Hit 0 on the touchscreen and just wait for the countdown to stabilize at exactly 0.000 milligrams per liter. Next, introduce a certified NIST traceable 1.0 milligram per liter standard solution. Input that value, press the green span button, and just let the processor automatically calculate the calibration coefficient. There's no need to dilute anything if it's within the unit's range.
We're getting close now. Section 5, parameters and final handover.
Over on the panel PC, set your measurement range from 0.025 to 1.5 milligrams per liter. Configure a 5-minute measurement interval. This is really the sweet spot for tracking source water fluctuations. Input your high alarm at 0.5 and your low at 0.05. Look closely at the transparent flow cell one more time. Visually confirm it is completely free of disruptive air bubbles, which will scatter the light and give you completely false high readings.
Now, you can't just walk away yet. You need to run a 2-hour trial operation. During this window, take a physical sample in a glass beaker and compare the screen output directly to your handheld DPD colorimeter. We are demanding less than a 2% deviation full scale here. Check your SCADA monitor to ensure the 420 mA signal is pushing the exact same value to the control room. Once that's all confirmed, sign off every single item on your handover logbook.
Here is your operational decision tree moving forward. It's pretty straightforward. If your residual chlorine jumps over 0.5, your HIL alarm triggers. You must immediately check your bisulfite or SMBS dosing system and increase the dose to neutralize it. But if it drops below 0.05, your low alarm triggers, meaning you have to investigate your primary disinfection system upstream and likely increase the chlorine dose. Between 0.05 and 0.5, you just continue normal vigilant monitoring.
Finally, let's wrap up with Section 6, interferences and data mapping. Your sample matrix really matters because false positives are your worst enemy here. Bromide, for instance, will cause artificially high readings because the machine will measure bromine too. Color and turbidity interfere directly with the 510 nanometer spectral light, so if you have high turbidity, you absolutely must use a 0.45 micron filter. Oils and surfactants cause foaming and inhibit the DPD reaction, requiring active carbon pretreatment. And chlorine dioxide? That causes a false positive, requiring glycine compensation. Identifying these interferences is key to reliable data.
Check out this exact 4 to 20 milliamp signal mapping. Notice the perfect linear relationship here. 4 milliamps is your baseline at 0.025, and 20 milliamps is your absolute max at 1.5. This translates directly into the formula your PLC uses. Concentration equals the current minus 4 divided by 16 multiplied by the span of 1.475 plus the base of 0.025. Verify this math is perfectly mirrored in your PLC programming.
Just to recap the core capabilities of the EZ1000 series, we're looking at a highly accurate colorimetric DPD method following ASTM standard 4500-CL-G. with an accuracy of plus or minus 2%. It really reinforces the strict, precise tolerances we've been working within today to keep those UPW systems pristine. I'm going to leave you with a provocative thought. Knowing that a single uncalibrated spike in free chlorine can permanently destroy your entire RO polyamide array, costing thousands of dollars and completely crippling plant production, are you truly confident in the rigor of your daily quality assurance checks? Take what you learned today, brothers, and execute it flawlessly. See you on the plant floor.